In section 5, we're going to talk about rational equations. So first we're going to start with a definition. So a rational equation is an equation containing at least one fraction whose numerator and denominator are polynomials. So notice how it says at least one fraction. So you could potentially have multiple fractions whose numerator and denominators are polynomials, or you could only have one, but it has to meet the criteria of at least one fraction. So the way we solve our rational equations is we do something called multiplying by the LCD. So in order to solve a rational equation, we multiply the numerator and the denominator by the least common denominator, also called the LCD, to clear the fractions and solve. So the easiest way to solve a rational equation is to get rid of the fraction part of the equation, and that way you're left with just an equation with no denominator, or at least a denominator of 1, that is easier to solve. So part of solving a rational equation is to look for something called an extraneous solution, or at least check. And extraneous solutions are when you get a solution to an equation that, when checked, is not a solution. So in the case of rational equations, this would be a value that when you solve ends up making the denominator 0, in which case it would be an extraneous solution because we cannot divide by 0 in a rational equation. So in the terms of a rational equation, it would be a value that makes the denominator 0. And extraneous solutions don't only occur for rational equations, they do occur in other equations, but specific to rational equations, they occur when they make the denominator 0. Let's go ahead and start with an example. So we want to solve the equation 5 divided by x minus 3 equals 12 over 2x plus 3. We could use cross multiplication, but we're going to stick with the method from above and identify the LCD and clear out the fractions. So the LCD, or the least common denominator, is going to be what would give us a common denominator for our fraction. In this case, our common denominator would include x minus 3 and 2x plus 3. So that would be our LCD. So now we want to multiply our numerator by our LCD. So we get 5 times x minus 3 times 2x plus 3, which is all over x minus 3, equals 12 times our LCD x minus 3 times 2x plus 3 over 2x plus 3. Now we notice in our first fraction over here, because the numerator and denominator both contain x minus 3, they cancel. And in our other side, both the numerator and denominator contain 2x plus 3, and they cancel. So we're left with 5 times 2x plus 3 equals 12 times x minus 3. And this would have been what we would have gotten if we used cross multiplication. But we still want to stick with the same method we're going to use to solve other rational equations that may not look like this. So now we can go ahead and distribute into our parentheses. So 5 times 2x is 10x. And then 5 times 3 is 15. So we get 10x plus 15 equals 12 times x is 12x. And 12 times negative 3 is negative 36. So now we can work on solving for x. So we're going to subtract 10x from both sides. So we get 15 equals 2x minus 36. Next, we're going to add 36 to both sides. And 15 plus 36 is 51 equals 2x. And last, divide by 2. And 51 divided by 2 is not a whole number, so we're going to leave it as a fraction, and we get that x equals 51 halves. Now our last step is to make sure that this is not an extraneous solution. So we want to go back and look at our LCD, and our LCD is x minus 3 times 2x plus 3. And 51 halves is not going to make either of those 0, which means that it is not an extraneous solution. So this would be our final answer. So our next example is 5 over x minus 3x plus 6 over 2x equals 7 halves. And we cannot use cross multiplication to solve. So we identify our LCD. So in this case, our denominators are x, 2x, and 2. So the LCD is not going to be all of them. It's just going to be the lowest or the least amount that's going to give us a common denominator, which is just going to be 2x. So we get 5 times 2x over x minus 3x plus 6 times 2x over 2x equals 7 times 2x over x. So we start seeing what we can cancel, over 2. So we start looking to see what we can cancel. In our first fraction, the x's cancel. Second term, the 2x's cancel, and our third, the 2's cancel. So we're left with 10 minus 3x plus 6 equals 7x. So distributing the negative in the parentheses, we have 10 minus 3x minus 6 equals 7x. Combining like terms, we're left with 4 minus 3x equals 7x. And now we want to start solving for x. So the first thing that we're going to do is add 3x to both sides. So we get 4 equals 10x. Then we're going to divide by 10. And our final solution is going to be x equals, and then we want to simplify 4/10, so we're going to be left with 2/5. And then we just want to double check that 2/5 isn't going to make any of our denominators 0, and it is not, so it's not an extraneous solution, so our solution is going to be x equals 2/5. So our next example is 3x over 3x minus 1 plus 1 over x equals 1 over 3x minus 1. So our LCD is going to be x times 3x minus 1. So multiplying all of our numerators by our LCD, we get 3x times 3x minus 1 over 3x minus 1 plus 1 times 3x minus 1 over x equals 1 times 3x minus 1 over 3x minus 1. So now we cancel anything that appears in a numerator and denominator. So it's going to be 3x minus 1, x, and 3x minus 1. So we're left with 3x times x, which is 3x squared, plus 1 times 3x minus 1, which is just going to be 3x minus 1, and then equals 1 times x, which is x. So because we have a squared term, in order to solve for x, we're going to have it set equal to 0. So we're going to subtract x from both sides. So we get 3x squared plus 2x minus 1 equals 0. So now we need to factor our quadratic to figure out our solutions. I'm going to do that over here on the right. So because our leading coefficient is 3, we're looking for the numbers that multiply to negative 3 but add to 2, which is going to be 3 and negative 1. And because our leading coefficient is 3, we're going to divide both of these numbers by 3. 3 over 3 becomes 1. So we're in factored form, we get x plus 1 times 3x minus 1. Setting each of these equal to 0 to find our solutions, we get that x equals negative 1 and x equals 1/3. So now if we check to see if either of these numbers will make our denominator 0, negative 1 will not, but 1/3 will actually make multiple denominators 0. So it is an example of extraneous solution. It is not a solution to our rational equation, and our only solution is x equals negative 1. So our next example is 2x over x minus 4 plus 10 minus 5x over x squared minus 16 equals x over x plus 4. Now, just because our denominator is x squared minus 16 doesn't mean it's part of our LCD, because if we factor that, we get x minus 4 times x plus 4. And if we look, that's just our other two denominators. So our LCD is going to be x plus 4 x minus 4. So we go ahead and multiply all of our terms by our numerators by our LCD. We get 2x times x plus 4 x minus 4 over x minus 4 plus 10 minus 5x times x plus 4 x minus 4. I'm going to go ahead and put it over the factor denominator, which is x plus 4 x minus 4. And then it equals x times x plus 4 times x minus 4 over x plus 4. So we cancel anything that appears in our numerator and denominator. I'm going to start from the right and move back to left. So x plus 4 cancels. In our second term, the x plus 4, x minus 4 would cancel. We go back to our first term, the x minus 4 cancels. So then we're left with 2x times x plus 4 plus 10 minus 5x equals x times x minus 4. So we go ahead and distribute our 2x into our parentheses. We get 2x squared plus 8x plus 10 minus 5x equals x squared minus 4x. Before I move any terms, I'm going to go ahead and combine all the like terms on my left side. So we get 2x squared plus 3x plus 10 still equal to x squared minus 4x. We're going to subtract x squared from both sides and add 4x. Which is going to give us x squared plus 7x plus 10 equals 0. And again, we have a quadratic, so in order to solve for x, we're going to factor. So in this case, we're looking to see what multiplies to 10 but adds to 7, which is going to be 5 and 2. So we get x plus 5, x plus 2, still equal to 0. Solve for when both sets of parentheses are equal to 0. We get x equals negative 5, and we get x equals negative 2. Now, in this case, neither negative 5 or negative 2 are going to make our denominator 0, so they are both solutions. So you can have multiple solutions to a rational equation. Next example, 3z over 3z squared plus 7z minus 6 minus 1 over z equals 4 over 3z squared minus 2z. So before we identify our LCD, we want to factor all of our denominators. So we're going to start with the 3z squared plus 7z minus 6. So if we set it up, we're looking for what multiplies to a negative 18 but adds to 7. Which would be 9 and negative 2. Divide both by 3. Nine over 3 becomes 3. So we have 3z over z plus 3 times 3z minus 2 minus 1 over z equals 4 over, and then I can actually factor a z from our denominator, and we get z on the outside, and we're left with 3z minus 2. So now we can identify our LCD. In this case, our LCD is going to be z times 3z minus 2 times z plus 3. So we're going to have to multiply all of our numerators by all three terms. So So when we go ahead and multiply our numerators by our LCD, we end up with 3z times z times 3z minus 2 times z plus 3 all over z plus 3 times 3z minus 2 minus 1 times z times 3z minus 2 times z plus 3 all over z equals 4 times z times 3z minus 2 times z plus 3 all over z times 3z minus 2. So now we can start canceling anything that appears in the numerator and denominator. With our first term, that'd be 3z minus 2 and z plus 3. Our second term would just be z, and our last term is going to be z and 3z minus 2. So now we're left with 3z times z, which is going to be 3z squared, minus, in parentheses, 3z minus 2 z plus 3, and then equals 4 times z plus 3. So now we have to distribute the 3z minus 2 to the z plus 3. And the nice thing is, since we know it's the factored form of one of our denominators, we know when we distribute, we're going to get 3z squared plus 7z minus 6. And it is important that you put this in parentheses because we are subtracting the entire term, not just the first. And then it's going to be equal to 4z plus 12 Our next step is going to be to distribute the negative, so we get 3z squared minus 3z squared minus 7z plus 6. Still equal to 4z plus 12. Combining like terms, we're left with negative 7z plus 6 equals 4z plus 12. So no longer have any squared terms, so we don't have to set it equal to 0 and factor. We can just solve for z. So we're going to add 7z to both sides. We get 6 equals 11z plus 12. Subtract 12 from both sides. We get negative 6 equals 11z. Divide by 11. And we're left with z equals negative 6/11. And that is not going to make z 3z minus 2 or z plus 3 0. So it's not an extraneous solution. So we get z equals negative 6/11. We have one last example. 2x over x plus 4 plus 7x plus 12 over x squared plus 6x plus 8 equals x plus 1 over x plus 2. So before I identify the LCD, I'm going to factor my second term's denominator. So it's going to factor as x plus 4 times x plus 2. So now the only terms that appear in my denominator are x plus 4 or x plus 2, so that's going to be my LCD. X plus 4 times x plus 2. Let's go ahead and multiply our numerators by our LCD. We get 2x times x plus 4 times x plus 2 over x plus 4 plus 7x plus 12 times x plus 4 times x plus 2 all over, and again I'm going to write the factored form of our denominator, which is x plus 4 times x plus 2. And then it's going to be equal to x plus 1 times x plus 4 times x plus 2 all over x plus 2. So now we can start canceling terms. Starting from the right and moving back to the left, we can cancel x plus 2, then x plus 4 and x plus 2, and lastly x plus 4. So we're going to end up with 2x times x plus 2 plus 7x plus 12 equals x plus 1 times x plus 4. So we distribute, we end up with 2x squared plus 4x plus 7x plus 12 equals, and if we distribute our two terms, we end up with x squared plus 4x plus x plus 4. So combining like terms on both sides, we end up with 2x squared plus 11x plus 12 equals x squared plus 5x plus 4. We do have squared terms, so we're going to want to subtract x squared, 5x, and 4 from both sides. So it's equal to 0. So we're left with x squared plus 6x plus 8 equals 0. So factoring x squared plus 6x plus 8, this is the denominator of one of our original terms before we found the LCD. So I know it factors as x plus 4 times x plus 2. solving for each x, we get x equals -4 and x equals -2. But because, as I already mentioned, x squared plus 6x plus 8 is one of our denominators, we know that -4 and -2 would make that denominator 0. -4 makes another one of our denominators 0, and -2 makes another 0. So they actually are both extraneous solutions. So since both of the values of x we solve for are extraneous solutions, it means we actually have no solution to our rational equation. Since both the values of x we solved for were extraneous, there are no values for x.